Okay, section 3.5, basic matrix operations. What we're looking at here is we're going to learn what is a matrix, how do you add and subtract matrices, and how do you solve matrix equations. Okay, so the first question, what is a matrix? Here's an example of a matrix. A matrix is just a rectangular array of numbers. Okay, and it's organized in rows and columns. Okay, the dimensions of the matrix is row by column. So in this case, this matrix is a 2 by 3 matrix. 2 rows, 3 columns. Okay. Each number inside the matrix is an element. So if I look at this number 5 here, that's the element in row 1, column 3. Row 1, column 3. The element in row 1, column 3 is 5. Okay, so that's just what a matrix is. Adding and subtracting matrices. In order to add or subtract a matrix, they have to have the same dimensions. Okay, so this matrix is a 2 by 3. This one is also a 2 by 3. So because they're the same dimensions, we can add those matrices and get a new matrix that's the same size. When we add matrices, all we do is add the element that's in the same location. Okay, so -2 and a -3 is a -5. 5 and 1 is 6. 11 and -5 is 6. 4, -2. -6, -8. 8 and 4 is 12. So you get a new matrix, we just add them up. Subtracting two matrices, again, they need to be the same dimension. So we have a 2 by 2 and a 2 by 2. Subtracting, same deal. We just subtract the numbers that are in the same location of the matrix. Okay, so this element 3 gets subtracted with -2, so 3 minus -2. Just be careful with your signs there. That's going to become addition. So you get 5. -2 minus -1, so that's going to be a +1. Or -4 plus 1 is -3. -1 minus 8, -9. And then 5 minus 3 is 2. So that's how we subtract matrices. Now if you don't like subtraction, remember subtraction is adding the opposite. So if I want, I could change the sign here and then change the sign of each item, each element inside the second matrix, and then just add and you get the same values there. Okay? Multiplying a matrix by a scalar. This number outside the matrix is called a scalar. It's just a number. Okay? And all we're doing is distributing -2 and multiplying it by each element inside the matrix to get a new matrix. So we just multiply. That's what we get there. Finally, the most difficult part of the section is solving a matrix equation. Okay, so in this case we have an equation that has variables in it that we need to solve, and it's inside matrices. So when we solve this, we need to start with the innermost operation here. So we need to add these two matrices together first. Inside there. This is our scalar out here, so I'm going to leave that out there. So when I add -3x to the same corresponding member of the other matrix, I get a -3x plus 9. I just write that as an expression. Okay. When I add -1 plus -4, I get -5. 4 plus -5 is -1. And then I have y plus 3. Okay. That's equal to this other matrix here. Okay, finally I'm going to multiply by the scalar here. Running out of room on my paper, so I'm just going to write it over here. So negative 2 times this is the distributive property. So that's going to give me 6x minus 18. Negative 2 times negative 5. Negative 2 times 1. Negative 2 times this is going to give me negative 2y minus 6. Okay, so finally, once I get it to this point, when I have two equivalent matrices, all I have to do is set the element in this matrix equal to the element in the other matrix and solve. So 6x minus 18 has to be equal 12. Then I just solve for x there. So we get 6x equals 30, so x equals 5. Same thing over with the y's. Set negative 2y minus 6 equal to negative 18. Solve that. Looks like I get y equals 6 there. So I've solved the matrix equation. Okay, so we've looked at what a matrix is, how do you add and subtract matrices, and how do you solve matrix equations. Okay, that's it for section 3.5.